Okay, so now we're going to do our next part. This is just some object I found out in the shop. I'm going to place it in the center of the paper for my front view. I do not expect you guys to use multiple colors unless you want to. I'm doing it to just show you what's going on. So I'm going to do the outside of the part, and I'm going to do my slots. So there is one view, the front view. Top view. And a right side view. And this one is all purple. There. Now, as best I can, these need to line up. So they more or less line up here. I don't have a ruler. They more or less line up here. That's important. Now, I have orthographic views, and I have them lined up. I didn't simply place these anywhere random on the paper. I intentionally try to form essentially an L with the orthographic views. So front, right side, and a top. There you go, guys. Now, next up, I'm going to get my length. It's a few thousandths under 4 inches. So I'm simply going to round that off. To 4 inches. Now, sometimes you might find this in parentheses. The parentheses mean this is a basic dimension. This is considered a perfect dimension. We're using bar stock. If you look at this material, hopefully you can see this, this has got kind of a wavy pattern. This is cut on a mill. Same with the other side, very coarsely. These are factory sides. So if a part came in, or a print came in, with this on it, I would make sure that I use 4-inch wide bar stock from the supplier. Now, it's not really going to be 4 inches. This one came out 2 thousandths under. It's normally just about the right size. Example of this, if you go to the grocery store and you buy a 5-gallon bag of potatoes, or sorry, not 5-gallon, a 5-pound bag of potatoes, they don't actually weigh 5 pounds. They're about 5 pounds. Remember, they're not cutting potatoes in half to get it perfect. So, same thing here. They're not going to mill this to size. They're not going to sand it down. They run it through a die. They get about 4 inches. Here you go. If you want it exact, you buy oversized and you cut it smaller, or you buy more expensive material. A good designer will know these sizes and plan accordingly to cut down on machine time. So, we got length. I marked as a basic dimension. The other way, I have 2 inches, 900 and 3 thou. Now, how do I get these? Well, previous video we measured the diameter of the hole. What we can do here is we can measure the width of our slot. And this slot looks to be 3/8-4. You can see that. So I'm going to measure the other two, see if they're the same. And they're within certainly within manufacturing tolerance. They're within a few thousandths of the same. So .384 slot 3 times. Now the length on these slots looks to be 1.125 or a little bit over. I mean, that's within manufacturing tolerance. Now, that is from the far quadrant to the far quadrant. If you actually think of how a slot is constructed, it is a circle and a circle, line in between, or each quadrant, and they mill everything out in between. So slots are normally measured center to center distance, not end to end. So what is that center distance? Well, 1.125 minus the width of the slot. The slot was probably supposed to be 375 plus clearance, but we'll go ahead and we'll take off 384 thousandths. Can't do this in my head. 1, 4. And I've completely lost track how I got there. So I really need a calculator for this. We'll come back to that while my assistant gets the calculator. So how do we know where our slot starts? Well, if that's 0, we would come over to edge of the center of the slot. So just like a circle, we can measure to the edge, 0.8, roughly 820, plus half of 384, half. I did get that right. Lost my train of thought while I was looking at a calculator there. 384 divided by 2 is going to give me around 190 thousandths, approximately. So 820 1.010. So that is probably supposed to have been originally 1 inch. And here I'm showing everything lined. How about these guys? Two inches, 55 thousandths. So 2.055 plus 0.190. 2.245. Probably supposed to have been 2.250. So here's my start, my datum, my origin, 1 inch away, 2.25 inches away. I could get fancy. I could tell them the stop point. So what do we do for that? This is a little harder because we kind of need to measure from the edge to there to verify it. But if we know our center to center distance, we can add that to the original 1 inch. So our center to center distance turned out to be, according to the calculator, 0.741. It was probably supposed to be 0.750 manufacturing and measuring tolerance. So 1 inch plus 0.75 equals 1.750. Now, I know we're always a few thousandths off in these measurements. Keep in mind, a caliper on a daily basis, a normal caliper, normal hands, they're good for plus or minus 0.005. So there's always going to be these little errors. Plus there's manufacturing errors, everything else. You add up, this is pretty common to have this little bit of difference on parts. Now, what about here to the center? Well, as mentioned before, take that, write it down. That is 0.925. Add to that the 0.190, and you'll get 5, 1, 1.115. Probably supposed to be 1.125. So 0, 1.125. There you go. Now obviously I wouldn't want all this crap on a print, but I would have this stuff. So the other thing I would do would be this one, and I would do that as well. But that's how we would do that part.